Hello everyone, and welcome to the Waveshare ESP32 Arduino Getting Started tutorial. One of the main advantages of the ESP32 series chips is their integrated wireless connectivity. Most ESP32 chips support 2.4 GHz Wi-Fi, making them suitable for various IoT application scenarios. ESP32 Wi-Fi supports multiple operating modes. The three most common ones are STA mode, i.e. client mode. In this mode, the ESP32 acts like your phone or laptop. It can connect to an existing Wi-Fi router, thereby gaining access to the local network and the internet. AP mode, i.e. access point mode. In this mode, the ESP32 creates its own Wi-Fi network, acting as a mini router. Other devices can connect to it, forming a local wireless network. AP+STA combined mode. In this mode, the ESP32 can simultaneously connect to an external Wi-Fi network as a client and act as an access point for other devices. In this lesson, we will cover the basics of using ESP32 Wi-Fi in the Arduino environment through 5 examples: scanning surrounding Wi-Fi networks, connecting to a specified access point, managing multiple network profiles with WiFiMulti, creating a Wi-Fi access point, configuring a static IP address for the ESP32. You can use the progress bar below the video to jump to any section you are interested in. The code and related instructions for each example can be found in the tutorial document linked in the video description. Let's start with the most basic function, scanning for nearby Wi-Fi networks. This example shows you which networks are available, their signal strength, channel, and encryption type. In the setup function, we first set the ESP32 to STA client mode using Wi-Fi.mode. Then we call Wi-Fi.disconnect to ensure it disconnects any previous connection. This is a good practice. In the loop function, the core function is Wi-Fi.scan networks. It starts a scan and blocks until complete, returning the number of networks found and stores the results inside the Wi-Fi class. After the scan, a for loop walks through all networks and retrieves details. Wi-Fi.SSID gets the network name. Wi-Fi.RSSI gets the signal strength. This is a negative number. The closer the value is to 0, the stronger the signal. Wi-Fi.channel gets the channel the network is on. Wi-Fi.encryption type gets the encryption type. Finally, Wi-Fi.scanDelete clears the scan results and frees memory. Upload the code to the ESP32. Open the serial monitor and set the baud rate to 115,200. You will see a list of nearby Wi-Fi networks with their names, signal strengths, channels, and encryption methods. The program performs a new scan every 5 seconds. After scanning for networks, the next step is obviously to connect to one. This example demonstrates how to make the ESP32 connect to a specific Wi-Fi network. First, define the network SSID and password. Set the two constants SID and password in the code, replacing them with your Wi-Fi name and password. In setup function, the core function for connecting to Wi-Fi is Wi-Fi.begin. Note that this function is asynchronous. It returns immediately without waiting for the connection to succeed. Therefore, we use a while loop to continuously check the connection status using Wi-Fi.status. If the status is not WL connected, the program will wait for a while and print a dot on the serial port to provide the user with an intuitive waiting indication. Once Wi-Fi.status returns WL connected, the connection is successful. At that point, we can retrieve and print the IP address assigned to the ESP32 with Wi-Fi.local IP. Modify the Wi-Fi credentials and upload the code. Remember that the ESP32 S3 only supports 2.4 GHz Wi-Fi. You will see the serial monitor print a series of dots while connecting, and after success, it prints the obtained IP address. In real-world applications, the ESP32 may need to connect to different Wi-Fi networks at different locations, or automatically switch to a backup network when the primary signal is weak. The WiFiMulti library implements this functionality. It allows you to preset multiple Wi-Fi networks and automatically connect to the one with the strongest signal. First, create an instance of the WiFiMulti object. Then, in Setup, use WiFiMulti.addAP function to add the candidate pairs of Wi-Fi names and passwords one by one. You can add as many as needed. The core function is WiFiMulti.run. It automatically scans, selects the best network, and performs the connection. Check its return value against WL connected in an if statement to confirm the result. In loop, keep calling WiFiMulti.run. If the current Wi-Fi disconnects, it will automatically try to reconnect to another available network from the list, providing auto reconnect functionality. After uploading the code, the ESP32 will automatically connect to the strongest network among those added. Besides connecting to networks as a client, the ESP32 can itself become a Wi-Fi hotspot, allowing devices like phones and computers to connect to it. This is AP mode. In this example, we first set the hotspot name and password. If a password is set, a secured encrypted hotspot is created. If the password is left empty, an open hotspot is created that anyone can connect to. The core function to create the hotspot is Wi-Fi.softAP. After calling it, the ESP32 starts broadcasting the specified Wi-Fi signal. We can get the ESP32's IP address with Wi-Fi.softAP IP, which by default is usually 19.2.168.4.1. In addition, we register 3 event listeners using Wi-Fi.onEvent. Arduino event Wi-Fi AP+STA connected, triggered when a device connects to the hotspot. Bound to Wi-Fi station connected. Arduino event Wi-Fi AP+STA IP assigned, triggered when a connected device obtains an IP address. Bound to Wi-Fi station got IP. Arduino event Wi-Fi AP+STA disconnected, triggered when a device disconnects. Bound to Wi-Fi station disconnected. When these events occur, the system automatically calls the pre-written callback functions. This event-driven approach is much more efficient than constantly polling the status in loop. After the program runs, find the hotspot named ESP32 S3 test in your phone's Wi-Fi list. Now connect with your phone. The serial monitor will immediately print the device's connection information. Disconnect, and you will see the corresponding disconnection message as well. Normally, the ESP32's IP address is dynamically assigned by the router and may change after each reset. However, in some applications, we want a fixed IP address so that the device is always reachable. This is a static IP. Let's look at how to configure it in STA mode and AP mode separately. First, look at STA mode. Create IP address objects to define the desired static IP, gateway, and subnet mask. Make sure to modify these values to match your own local network environment and ensure the chosen IP address is not already in use by another device. Additionally, Wi-Fi.config must be called before Wi-Fi.begin. In AP mode, the configuration is similar but uses the Wi-Fi.softAP config function. Again, define the hotspot's IP address, gateway, and subnet mask first. Wi-Fi.softAPC config must be called before Wi-Fi.soft. AP creates the hotspot. Well, that's it for this lesson. We learned several core Wi-Fi usages for the ESP32: scanning surrounding networks, connecting to a specific Wi-Fi as a client, using WiFiMulti for automatic selection of the best network, creating a Wi-Fi hotspot with the ESP32, and finally, configuring static IP addresses for both STA and AP modes. In the next lesson, we will learn how to turn the ESP32 into a web server, allowing you to control it through a browser. Thanks for watching, and see you next time.